When we talk about surface waters, we can't ignore flooding. So the amount of water in the river channel fluctuates, right? There's flood conditions and drought conditions. Humans can control these levels through dams. We have dams that are flood control dams. We can divert water and control the amount of water that is coming through the system. We can put in levees, artificially high um, ridges or walls parallel to the stream channel. We can channelize streams. All that can control the water level in a stream. Kind of gives us a false sense of security because levees can break, dams can break, channelization can make flooding worse downstream. Um, it can elevate the water, so we have more of a discharge problem because of that human influence on the stream. There are two processes that happen in a floodplain. One is lateral migration. So this is what we were looking at with the meanders, where the cut bank is being eroded and the point bar kind of comes in behind it and that whole stream channel moves. So through that, it's constantly reworking the sediments of the floodplain. So as you have that lateral migration, you also have vertical deposition going on when we have overbank flow or a flood event. So if the water exceeds the carrying capacity of the channel, then fine-grained sediment gets put in thin layers, horizontal sheets across that floodplain. Usually it's going to be silts and clays and organic material in that flood deposit. All right, with flooding, we can't ignore the Mississippi River. It has had a long history of flooding in the middle of the United States. For the longest time, the Army Corps of Engineers has been trying to control the flow of the Mississippi with levees, reservoirs, dams, all up and down the course of the Mississippi. In 1927, there was a big flood that the levees failed in 120 different spots and killed hundreds of people. We didn't learn very much from that because in 1993, there was another event where there were levee breaks up and down the Mississippi corridor there. The Army Corps of Engineers has straightened the Mississippi in a lot of places. 200 kilometers of shortening has occurred. So the Mississippi would meander, but instead they've straightened it, and so it's lost some of its length. Through that, there's been lots of loss of wetlands. Wetlands are very important to the ecosystem in the area, but also there are places where floodwaters collect, which is a good thing, and then slowly let that water infiltrate to become groundwater versus just keeping it all levied into the stream channel. The Army Corps of Engineers has a constant fight on its hands. In that book where we read about the control of nature, there's a chapter about the Atchafalaya River trying to steal the Mississippi. So right in this area, the Army Corps of Engineers has to maintain the Mississippi, keeping it in its channel. So the 1993 flood, more levees failed, so 800 levees failed. Part of that, they had to actually blast some of their own levees. It was the first time the Army Corps of Engineers ever blasted its own levees, but they were trying to get water to go back into the Mississippi, and so that they had to remove some levees to make that happen. This 1993 flood happened in the late summer, so a lot of crops were ruined. The levees were made of sand, and when they failed, they dispersed sand over the crops, covering fertile farmland with infertile sediment. The heavy rains were up in the top of the watershed for months and months, 2 months of straight rain. And so that maybe there wasn't any rain in the further down the watershed, but they knew the flood was coming. So it's kind of predicted, like they knew what day they were going to get the flood because it was coming down the watershed. As a result, after the 1993 flood, there was some movement. Towns, actually whole towns, were moved to higher ground up on the bluffs above the Mississippi out of the actual floodplain. Water got trapped behind the levees. It's just like when Hurricane Katrina happened. Water gets behind the levees and just sits there and can't get back into the stream channel. So here's a look at the Mississippi River in the top. Is a normal flow in 1991. And then a similar day, same week, in 1993. It was almost like it turned into big lakes along the Mississippi River. So channelization, we looked at it a little bit when we saw that straightened stream in the pasture. Channelization is straightening, it's culverting, it's man-made ditches, it's lining streams with concrete. It does act to move water downstream faster. So like in the case of campus, we have ASU sitting on the edge and partially in the floodplain of the Boone Creek. And we've channelized the heck out of Boone Creek. And so that's one of the reasons why the mall parking lot floods when we get a big rainstorm, is we're moving tons of water out of the system down to the mall parking lot. And that becomes like a catchment basin for all this water. So channelization, it does move water, but the downstream can suffer. It does drain land for agriculture, but we're draining land that would be like a wetland for agriculture. We're draining it for development. Through channelization, if you're lining it with concrete, you decrease the roughness. So one way to combat that is to add some roughness to your concrete. So that's something that is happening these days. If you do have to culvert a stream, is to give some roughness to the concrete. You'll see streams go through pipes, and they'll corrugate those pipes. Stream variability decreases. So a stream, natural stream channel, is going to have pools, riffles, and rapids as it goes. When you channelize a stream, you decrease pools and rapids, and you increase the amount of riffles. So a riffle is just riffly water where you have rocks and water, versus a pool where you have maybe some stagnant water in places. So it changes that variability to just having riffles, no rapids, and no pools. The gradient gets steeper. When you steepen that stream channel, then you increase the velocity. And then when you increase the velocity, then you increase the erosive power. So stream channelization changes that whole environment. If you're not storing water upstream, you're moving it through the system, then the downstream environment is going to have more water and as a result, an increased erosion. Here's what a riffle would be, this section here. This is a pool, and here's a rapid. Here's an area then that's channelized, and see, you have pretty much the same flow regime throughout the whole channelization, and it's ugly and gross. Here is a stream channel that has majorly been channelized, right? So here's the flow. This looks like an irrigation canal. And then left over here on the side are old meanders from the old flow pattern of the stream. They just cut all that off, cut the meanders off, and made it channelized. Here's a channelized stream. So in areas like around LA where they just can't have water flooding the city, they have these, you see these in movies around LA, ditches where they collect the water. Here's channelization and irrigation. This is lined. You can see it's very manicured and lined streams. In areas where they do line the streams like this, there's a lot of evaporation out of that surface water. This is a natural flowing river, so this is what we would expect a natural river to look like. This is actually the Wilson Creek down just off the mountain. That looks way better than that, right?